Now, several of those rules that they shared with you there are good visual representations of what that means, but using it, I feel like, makes it a whole lot more easy to recognize. I'm going to show you several reciprocals really quick and help you kind of visualize all that. So this isn't in the book, this is just for me. So if I say 4 multiplied by what number will give you 1, you know that whatever the number is multiplied by its reciprocal will give you 1. So in order to multiply this and create a 1, you multiply by its reciprocal, which is basically that number inverted into a fractional looking form. And you can check yourself by taking this and dividing it by that when you're looking for what the reciprocal is. And in the end, you can check this to make sure it's true. 4 over 1 multiplied by 1/4. Does that equal 1? Yes. Even if it's a negative number, -3, the reciprocal stays the same sign because the product needs to be a 1. -1/3. So the reciprocal of -3 is -1/3. Variables can be mixed into this as well. Say -x over 3. What would the reciprocal of that be? What do you think, Lee?
1 or x.
So what's the reciprocal of this was my question.
It's negative x and 3.
No.
No.
Mm-mm. Okay, so let's just go back over this. So look up here. If you have this number, flip it. That's the basic relationship of the reciprocal. Positive, positive. Even if it's a negative, you do the exact same thing. Flip it. Okay? Down here, the rule is still exactly the same. So what will its reciprocal be? No, not 3 over x. There you go. Bravo, my dear. Yep. The sign doesn't change. You just flip it over. And like that first one, if you don't have a number, if it's a whole number, just plug a 1 under it so you can visualize flipping it. Using reciprocals, that thought process can help you to simplify a lot of the things you do as we head into some more detailed math. Let's look at example 1, and this is out of my notes. You can always refer back to your book. You might think this doesn't really have anything to do with reciprocals, but I just want to share it with you anyway. Notice that little negative symbol is floating in front of the -4, in front of the 4. When you look at a fraction, this literally means 1 divided by -4. If you take 1, plug it in your calculator. I'm not sure if mine has this little feature that I want to show you. 1 divided by -4. Yeah, it does. Okay. If I take my calculator and I say, look, that's 1 divided by -4. 1 divided by -4. The end result is -1/4, right? It doesn't matter where the negative symbol sits. The quotient of that division, if you thought of it as division, is negative. Which means writing it like this is the same thing as writing it like this, which is the same thing as writing it like this. When you have a negative fraction, where you drop that negative symbol is irrelevant. All that means is the end result of that division, as we just showed here on the little division that we did in the calculator. The end result is negative. In any case, the result of this multiplication is negative 1/20th. Remember, it doesn't matter where you float that negative symbol. It doesn't matter, because the end result of the division makes that quotient negative. Do you guys understand what I'm saying about where you put the negative symbol for a fraction? Okay, very good. I don't want you to get bound up in that. Next one. This is still part of example 1. If you have a, lost my place there for a second. A fraction being multiplied by a variable like this. 9 times m is being multiplied by 1/9. What can we do there? Using your basic multiplication of fraction knowledge, any ideas? Kat, what do you think about these 9s? Jay, how about you? You want to help?
We should divide 1 by 9 and then multiply it by the 9.
And no. So when you multiply fractions, what do you do before you multiply them? You reduce them. Yeah, don't forget you can still reduce them, even if there's a variable attached. So the end result is 1m, otherwise known as m. Whenever you have a whole, even though this is a variable, throw a 1 underneath it. If you didn't reduce it, you would end up with 9m divided by 9. And the 9s would reduce here, leaving you with m. And that would be your end result. These reduced each other completely. This last one I want to show you doesn't reduce it completely, but it reduces it somewhat, which is helpful anytime. 64ab, whoops, ignore that for a minute, times 1/8 negative. Before we even get into anything, is the product of this multiplication going to be negative or positive? Positive, good. So right off the bat, and I'm only going to put that there just so that I remember. You don't have to if you don't want to. Are the 8 and the 64 reducible? Yep. And I would have then put this line here just to remind myself. 8 goes into 64 8 times. So 8 times A times B times 1 is 8AB over 1, which you don't have to write. So the end result is positive 8AB. This next bit, example 2, is where it gets a little bit tougher. I'm going to do a couple of these examples with you. Here we go. Negative 1/6 is being multiplied by negative 24x plus 6y. We're distributing here. The negative 1/6 gets multiplied by both pieces. So this first piece is like negative 1/6 multiplied by negative 24x. Okay? The second piece is negative 1/6 multiplied by 6y. We're going to uncover the answer to each piece independently and then join it together so that it looks like an expression. Are the 6 and the 24, can they reduce each other? Yep, by a factor of 6. Real quick, Negative times a negative, what is the result gonna be here? Positive. What's it gonna be? 1, 4,
This is Brandy Stockenberg. You've been employed and taken directly to the office today.
altogether, what do we get for this piece? Yep, 4x, good. And let's quickly get the result here. Is it gonna be negative or positive for this last piece? Negative, so I'm gonna put that negative right here, just so that I don't forget. Can anything be reduced here? 6s, they're gone. So what is the result of this? Y, good. There's your answer. Okay, one more. Actually, I'm going to do 2 more with you. Negative 39 and minus 52p. Negative 1/13. Okay, what's happening here? What's the activity that we're going to do? Yeah, sorry. We're going to distribute. We're going to multiply that negative 1/13 by each piece within the parentheses. Even though it's written with the little piece that's getting distributed at the end, it doesn't change anything. And it doesn't even matter which order you do. I'm going to do the 39n piece first, which would look something like this. And then we'll do the second piece. And if you have to write it like this, do it, just so that you can keep it nice and neat. All right, let's look at this piece. The 39 and the 13th. What will the result here be, positive or negative? Yep. Can anything reduce? Can the 13 and 39 reduce? By how much? 3. Looks like you have 3 times n then for that piece. How about the 52 and the 13? What's that going to reduce by? 4. Will this be positive or negative? Yep. 3n plus 4p after you've done all that work. Last one. Last one I want to do with you. Okay. So what this is saying is the sum of this product and this product. But first we just have to do the work. So you've done all this. We just now have to finish off by adding them together after we've solved each piece. So right here we've got negative 8 being multiplied by negative 1/8. And we've got negative 8 being multiplied by positive q. I'm working this left side. The first piece, negative 8 multiplied by negative 1/8, is how much? 1. It reduces, so it's just 1p. Next thing, is there anything that can reduce? Nope. So p minus 8q, would you agree with me that we have that piece done? All right, let's go to the next one. we've got 1/9 being multiplied, and that's positive, being multiplied by 63p. And we've got 1/9 being multiplied by that. Can anything reduce here? 9 with 63 becomes what, a 7? So the product of that is a positive 7p, am I right? And here? So what's the end result? What kind of Q? Negative. That's huge. Huge, huge, huge. Let's collect our variables. We've got a positive p and a positive 7p. What's the sum of that? Good. And then let's collect our q's. What's the sum of that? Negative 9q. Yeah, good. This here, I know takes up a lot of space, but if you break it out like that and take your time, it's a lot easier to see and correct any errors.